Like the numbers are leveling off a bit. So we'll go ahead and get started here. Thanks for joining us, myself and Matt Plouse. Matt is a GIS analyst here at DATAMARK. My name is Jeff Ledbetter. I'm a client success manager. You watch these webinars regularly, you see my face more than you probably want to. But we're here to talk about a new topic in this that we haven't talked about before in our webinar series about routable networks. Not everybody has a grasp on what a routable network is, so we're going to spend a little time on that today. What a routable network is, what some basic requirements are. Matt's going to do a bang-up job of showing us some examples from some of our projects where there are definitely some peculiarities and things you need to think about how your GIS data works in a routable network. And then he's going to take us through some of the painful parts. And if you work with GIS data, you know there are definitely painful parts, and putting it into a routable network brings a whole new set of challenges to that. So let's talk a little bit about what a routable network is. If you were to just type in routable network in Google, you'd get a bunch of answers back about a bunch of different types of networks, including computer networks, IP networks that are routable. That's how the internet works. You get some entries about utility networks like water and electric networks. You might get some information if you just get through enough pages of answers. You might get into how networks relate to road center lines for routing. So it's kind of a broad term that could apply to a lot of different things, but obviously we're talking about how a routing engine might be used in a CAD dispatch system to give routing recommendations to first responders in this case. You do want to think about how a utility network works when you think about a routable network as well. If you see the picture on my screen here, and actually I'm gonna turn my video off so that I don't have any bandwidth problems here. If you see the picture on my screen, it's a screenshot from somebody's utility management system for a water system. And you can see it's got little meters, little valves, big pipes and smaller pipes. And so it's really a model of how the system works. And it allows the type of analysis that would say, if I have a water break in this portion of my main pipe here, what customers go dry, what customers don't? Will it be able to reroute from this union here? If I turn this valve off, where does the water go? Similar to an electric network, if backhoe takes out a circuit, can I backfeed that circuit? What switches do I need to turn off so that when I do backfeed it, I don't electrocute anybody at that break? And so think of a routable road network for CAD dispatch routing recommendation purposes in a similar way. Think about flow of vehicles, flow of traffic, and you can think of traffic lights and stop signs and things like that as places that introduce friction. We'll talk about friction in a minute more. But there is an important distinction that I want to call out of a routable road network. It's more than just the road center lines that you might use for, say, NG911 call routing or just visualizing a road map. It actually includes additional segments that really represent anywhere you want wheels of a vehicle to roll. So there may be parking lots or other private roads that you would never put on your road map, but you want to make sure that it's a routable path. So you might include pass through parking lots, particularly in large facility parking lots like malls or stadiums or things like that may have a maze of different parking lots or routes that you might need to go on. that maybe even are on private property. So they don't belong in the road centerline network because there's not addressing going on off of them, but there would be a desire to roll tires down that particular piece of pavement, and maybe even not even pavement. And so a routable network for a routing engine to consume really provides data for that routable path. There's an important concept about nodes. You can think of nodes as where intersections occur or where two road segments or routable path segments connect. Those nodes contain information in them or can contain information in them on where the flow can go beyond that intersection. It either stops, it turns right, it turns left, it goes straight. The flow can go from even decrease, like a 4-lane road, to a 2-lane road. There may be a node at a lane stricture that would communicate to the routing engine that your traffic is going to flow less fast here or with more friction. And then finally, that concept of impedance is anything that slows things down or friction, introduces friction. Like I said, if you narrow a road from 4 lanes to 2, there's going to obviously be friction. Traffic's going to be slower at that point. There's going to be more backups and things like that. The concept of having a speed limit attribute in your GIS data can be used as an impedance. My personal recommendation is always to allow a speed limit field to actually communicate speed limit, not impedance. That it's better to have a separate impedance field where you can slow things down. If you want to discourage routing along a certain road for any given reason, you could increase the impedance value of the impedance field and not mess with the speed limit. But sometimes you can't do that. Sometimes the system's been built in a way that uses the speed limit field as to communicate impedance or friction and kind of move things around, move that routing recommendation around. I think some of these concepts will make a lot more sense when we get to see Matt's examples, but an important high-level concept there is about nodes and impedance. It's important to note that different routing engines have different requirements, and so in a world with a million choices of CAD systems, there's almost always going to be some overlap in these concepts that work for any routing engine, but there's also always going to be some peculiarities that CAD company A versus CAD company B uses, because they generally speaking, they apply their own routing engine that has its own rules and its own methodologies of calculating, and frankly, its own set of things that it does calculate that are important to it. So they create a routing engine that's, geared more towards a fire engine or fire response versus a law response, things like that. The requirements may be different, the geometric and spatial requirements, as well as the attribute requirements. And so that top note there is really just to say, be sure that when you're working on a routable network, that you are familiar with the routing engine that's going to consume it and the requirements that it has, and tailor your GIS work to those requirements. Secondly, you want to think about your spatial representation as well. Sometimes you think of a road with a boulevard down the middle of it with trees. And you may think, you may have one line that represents that road. And for a typical road network, that may be fine, especially if it's got address ranges and it's typically there to geocode an address or something like that. But when you're thinking and you change your mindset a little bit about routable networks, change your mindset to where you want tires to roll. Sometimes you have to you should note in that boulevard situation that you're not going to turn left against a boulevard. You may be able to turn right onto a intersecting street or routable path of a parking lot or something like that, but you're not going to turn left against a boulevard. And so you're going to need things like turn restrictions noted in there as well. And when you have a turn restriction, and one of the best practices is to think about your spatial representation. The single versus multi-carriageway is the terminology that's typically used. If you represent the single carriageway, it's just like on the picture here, you see Anderson Road represented as a single carriageway because there is probably not a boulevard on that. Or if it's a divided road like this, I'm going to say Caravan Way. I can't actually read the letters there. Those two lines together heading north and south, they're actually representing the same street, but they're divided lanes. They've either got a boulevard or they're just divided the way some highways are divided. So that's an important concept that you'll have to think about when you're planning your routable network as well. We also want to note that some of the mechanics, some of the concepts of mechanics of how these things work is it takes advantage of node connectivity. So if you see the arrows coming together at the intersections, those are where the nodes or the endpoints are at. And how you connect or don't connect, either purposefully or unpurposefully, connect those nodes communicates to the network and to the routing engine that you can move forward, that you can turn right, that you can turn left, or that you must stop, and it's a dead end. Sometimes, and Matt will get into some QC stuff in just a few minutes, sometimes unintentional mistakes in connecting nodes causes a lot of problem with the routing engine and may give trouble routing an engine or routing a response recommendation way around the easiest path because there are undershoots or overshoots. The concept of elevation is important as well. And again, you'll see a couple of good examples in Matt's graphics where overpasses, underpasses, ramps that connect different elevation paths are really important as well, so that the routing engine doesn't see that overpass as an intersection. Instead, it sees that it's just an overpass over a highway, for instance. Thirdly, we talked about impedance already, but impedance introduces friction and meters out the friction as well. So you'll want to have some thought about what's my philosophy going to be about using impedance to discourage routing down a certain segment or encourage routing down a certain segment for real world reasons like traffic's always bad on this segment, or it's along a boundary and we don't want to come near the boundary. Turn restrictions as well. As I mentioned, you're not going to turn left across a boulevard because it's a physical impediment. May have a fence in it even. So you'll need to note your turn restrictions segment by segment in a routable network. So the routing engine doesn't think you can turn left when you actually, in fact, cannot. Sometimes there's even turn restrictions because we know that there's a gate on a particular facility or something like that that is not accessible to public safety responders. And so you may put a turn restriction on a road there to say, don't take this right-hand turn or this left-hand turn. Finally, you always want to be thinking about maintenance and data quality and quality control, quality assurance measures that you would undertake in any data set. They have their own peculiar requirements here as well. There is things to think about like the format, the relationship, and the validation of the data. You hear us here on these DATAMARK webinars very often talking about our validations that our VEP product uses to validate, edit, and provision GIS data for NG911 call routing. Some of those validations are going to be valid to a routable network, but some of them are not. And there's going to be other validations that are important to a routable network that aren't to NG911. So when we use the term validations in this particular context, we mean a whole different set of validations and concerns than we do for NG911 call routing. There should be, again, the routing engine requirements should drive these validations. There should be checks against spatial to be sure that nodes are connected appropriately or disconnected appropriately. Make sure that the geometry types are all usable to the routing engine. And then, of course, there's always attribute values that need to be checked as well, because in some cases you may need a turn restriction value, and you should be able to sort of automatically check to see that you have a turn restriction value if you don't, for instance, or you have an elevation at an intersection that overlaps, or is maybe an overshoot, not an overshoot, but you should have some validations that highlight an alarm on some certain things like that. One good methodology or tool to use in your QC validations are to create points at intersections. So where you have those node connectivity points, you can create points to make sure that you haven't missed a connection that should be connected, or that you haven't connected something that doesn't need to be connected. In addition to that, it's also a way to communicate that friction if necessary. Snap 2 points is another good methodology or tool you can use where jurisdictional boundaries exist to be sure that even though you have two different jurisdictions maintaining road centerline locations or routable path locations, that they line up. Where MLK Boulevard goes from one city A to city B, make sure that city A's representation lines up at a node endpoint to city B's representation. And as always, we'll always encourage considerations around maintenance and data supply chain, especially if you're working in, again, a multi-agency PSAP that may have a CAD system that services more than one agency, more than one jurisdiction. You may need to get data from two different cities or a city and a county. You're always going to have to think about, where are my updates going to come in? What does the data governance around those updates look like, so that I can be sure that my routing engine is always maintained and up to date as possible. So at this point, that's what I've got for some very high level basics for you. I'm going to turn it over to Matt and let him get into some good examples of some peculiarities we've run into in some of our project work. Take it away, Matt.
Thanks, Jeff. Okay. So like Jeff said, we have some examples of unique and I would say challenging situations that we've come across so far. In this particular example, and I'm going to, I think, hit my camera off here, just in case. Okay. In this particular example, on the left was the original data, and the arrows represent the flow of traffic. So, with NG911, we like to represent our roadways sometimes with the flow of the address points, but in this particular case, the arrows represent the actual flow of traffic. In the left example, you can see that this is a half divergent diamond intersection where there's ramps coming off and going on to the interstate here. The interstates are going the right way, but most of the ramps are going the wrong way. And this is another great example of where these would need to split at where they go over the highway. And then these would need to be changed for elevation to account for the bridge. So then obviously your routing system would not try to turn somebody off the bridge, because that's less than desirable. And we changed, obviously, in the northwestern corner here, the ramp's going the opposite way. You can see some of the directions in the divergent diamond are going the opposite direction. And there's just a better flow through each of the intersection to make sure that your directions are correct. There's multiple ways to do this. You can change the actual geometry of the line itself, or you can use the one-way, because these are mostly one-way roadways. You can use the one-way to from, or from to, or however your CAD system or your routing system takes that input. You can change that to change the direction of the flow of traffic based on if you don't want to change the actual geometry of the road, you can just attribute it differently. Okay. And this is another great example of, you want to make sure, I know Jeff mentioned, you want to make sure that you're adding in all of your, where you want to put tires, right? I think that's the way he said it. So in this case, you can see in the left image, there's no crossing there, and there's not even a break in the roadway for anybody to know that there's a way to turn around here. So what we did was, we actually used Street View, and we went down through Interstate 10 here and broke the road and added in turnarounds so that it could be routed anywhere along the way. So, it's hard to catch, I would say, sometimes an aerial, but you can always, if you're local, obviously you can just drive out and note those locations, or use Street View was another great option for us. And again, more on talking about the adding in all of your drivable areas. So in the top two images, you can see we added in the roundabout. And you can keep that the same speed limit, but I think we've all driven through roundabouts and it's probably a little bit slower. And Jeff said not to use speed as an impedance, but you could also attribute that a different way to show that that's probably going to be a little bit slower of a pass for, say, a large fire truck than just driving straight down a road. And then, and again, we showed the dual carriageway on the right, compared to where it was just a single road going down the center. And then the bottom, again, is just another great example of that was just a single segment going through the middle of that little area grass, what probably should be a grassy area, and adding all the turn lanes in each of the directions. That's critical to making this thing as accurate as possible for your network. And again, just to kind of really hammer home the adding in all the lanes, this is another great example. We went from single lanes to dual carriageways, added in ramps. And there's a lot of individual segments here that were not included in the original, the original data that is now being represented and can actually be driven. So we had some pain points and questions that were submitted. And I'll go through some of those now. So we had somebody ask about required fields. And again, as Jeff said, this really depends on your CAD provider and the level of detail you want. I would say street names, address ranges are great. City, county codes or names, one-ways, speed limits, and the elevation codes. So the elevation classification is not actual elevation. You're not worried about elevation above sea level. You're worried about the number of levels it is above zero. So you mark, at least in the example on image on your right, their ground level is 0. So that would be the main highway underneath the main highway underneath going north to south. That would be 0. And then each individual level up would be, you would add 1 to. So the next bridge up would be 1, the next bridge above that 2, and then this one actually has 3 levels. And then the same works if you have tunnels. So you would go -1, -2, etc. So again, work with your CAD provider or your routable network provider to figure out exactly what you need and what works best for your particular instance. But those are great starting points. We had another question, was speed limits of undivided roads that are different for each direction. And Jeff, if you have input on this, that would be appreciated. But you obviously you want to check with your CAD provider again. You could, as high level suggestions for that, you could add a segment for either side of the road. Um,
Yeah, that's where some of the advantage of the dual carriageway spatial representation comes handy, because each one has its own attribute values. Each one could have its own impedance, its own speed limit, its own name. Like Scott asked about the names of turnarounds, if you have different turnarounds or crossovers that aren't necessarily road name differences, if you represent those spatially as either a dual carriageway, or obviously the crossovers and turnarounds would have their own geometry, you can give some customization in things like names and impedance values.
yeah. Um, but yeah, that's another thing to, you want to work with your CAD provider and get the best result. Maybe they have a left and right speed limit,
Yeah,
possibly.
yeah.
Um,
Most
for
cases,
un Sorry, Jeff, go ahead.
I was just gonna say, in most cases, they would have a left and right speed limit value.
Perfect. Updating and maintaining attribution was another common theme that we saw. Um, Getting started, there are great sources of information. Some cost money, some don't. It depends on the investment you want to make. You can purchase, like I said, you can purchase data. You can go to other sources of data. If you're a municipality within a county, the county might have roads that'll have some kind of data, maybe speed limits or one ways, or at least street names if you're missing those, or roadway classifications, that kind of thing, or even your state. I mean, each each level of government has their own kind of representation of roads, all the way up to federal government. But as you get higher, you lose quality of, the details that you probably need for this type of thing. Another way is just manual attribution. You can use Street View. You can set up a Esri collector app, and send somebody out and drive the roads and get speed limits. And I mean, that's obviously not financially possible for everybody, but if you can build these things together, get your main points, and then where you have little pieces that may not, you need to fill in gaps, you can always send somebody out to take a look, or drive a long way on the way home and swing by the road that you are in question of the name, or the speed limit of that particular road, and see what it is with the street signs. And then maintaining naming conventions for multiple uses. So one example that I have for that, we had a client that their data had to represent four separate things. So, they had NG911 and then a CAD system and, a couple of other things, and they needed unique data for each one of those things. So what we did, and what you could do yourself, is we wrote scripts that pulled the data, took the main data and then altered it however that needed for that CAD for whatever system. So, for NG911, it pulled out the Nina fields. And then the CAD system, it was obviously other things, for their routable network and whatnot. So something like that, it's kind of complex, but it's one way of having one set of data, and not having everybody has data, which lose things, right? Another way, if you're not too familiar with writing scripts and whatnot, excuse me, you could obviously have duplicate fields. That's not optimal within that same data set. And then, when you're populating a new road, you could put in the street name in the format you need. Or if you're just looking for different types of labels, you could do, there's lots of ways, especially if you're in the Esri environment, to change the labeling and you can write a lot of things with, a quick Google search kind of would help, to alter things, take things from all caps to title case and that kind of thing. So um, that's kind of my suggestions there. Um, testing. Um, so testing your network, making sure that you didn't miss anything, or you don't have the nodes that you need. So Jeff made a great point about topology. I think topology is a great starting point, right? You want to make sure that your roads, everything is snapped. And because if they're not snapped, they won't connect there, and then you're losing potentially, you're sending somebody on a detour that didn't need to be taken. You can, if you have Esri products, there is Network Analyst. You can load your data in a Network Analyst, and there's lots of tools within that toolbar that can help you kind of determine, or even just run tests, test runs on your data to see how it runs and if it's completing correctly. And there's, like I said, there's all kinds of things in there that help. Again, that's an added up charge. And another thing you could possibly do is work with your provider. See if you can get a test instance. I don't know if that's common or not, but it would be amazing if you could have a test instance. You could run it through your CAD, or have a test CAD where you could check things, and then before you actually physically loaded the data into your live CAD. And then complex intersections. We've kind of talked about this, and but I did bring this image here from a current project. It's a lot. It's a couple of highways coming together with all kinds of roads. And somebody asked about how do you navigate these troublesome intersections. So what I like to do is I'll start with one road and I'll follow that the whole way through. And doing my attributes on each segment of that particular road. And then once I get like in this particular instance, because there's so much elevation, you can you can symbolize your roads by elevation, and then it helps you can see things a lot easier. Again, topology would be amazing here, but I like to just, in these really complex intersections, just take it one piece at a time instead of trying to address the entire intersection in one chunk. One road at a time, go through the whole way through until you're back to a place you're confident with, and then just keep doing that until you've worked through all of your individual pieces. Again, you can turn on and off different levels, again, if there's elevation, or that's another way to kind of help see things a little easier. But yeah, that's what I have. Jeff, do you have anything to add?
Yeah, you said something about the idea of kind of how do I figure out speed limits without necessarily having somebody go in a car, and or like you said, Google Google 360 pictures are useful, but you can also think about using a road classification system to help you get a starting point. Not everybody has classified roads, but if you do, they could be very advantageous in this regard, because typically your major arterials are going to have a speed limit that are something like 45 miles an hour, and your local streets are going to have something like 30 miles an hour. That's probably a good starting point, kind of like good enough to get started. And then as exceptions to that are noted, if you update and maintain those, or go out, and I think you made a good suggestion, just where there's going to be issues, or where you have complicated intersections like the one in the picture, just go out and have somebody spend some time in the field making observations about the elevations, about the speed limits, about kind of where there's a lot of traffic or a little traffic, where there may be challenges getting the right equipment on that road. You know, especially if you're working for a fire EMS, those are big vehicles. Sometimes some of the roads are very small, and maybe you want to use an impedance or a speed limit to kind of discourage routing through those streets and prefer rather the kind of major streets. So there's a whole lot of depth to this topic and could be a lot of different questions and concerns about a lot of bits of the data. But generally speaking, if you kind of take a 80-20 solution where we can infer 80% of it and we can verify 20% of it, it'll get you going a little bit quicker with less like you said, costly solutions of labor. Whenever you get labor involved, is very costly. So that was one thing that occurred to me we could add to it. Yeah, it doesn't look like we had a question or two. I think we've answered those. If anybody has any more questions, you could put it in the chat, put in the question and answer. If not, this is our high-level overview on Routable Networks concepts and some examples. Hopefully it's been beneficial to you and given you some things to think about. This is something that the DATAMARK team is experienced with, and if you need help and expertise in that regard, we help clients from multiple different CAD systems tailor their data to the needs of those CAD systems. So if you have any questions about anything we've said or talked about, or you need some routable network therapy, like we talk about addressing therapy sometimes in our webinars, feel free to contact Matt or myself. We've got our email addresses up here. You signed up for the webinar here, so you'll be notified of the next webinar, but we'll have another one in October, and we'll look forward to seeing everybody then. Thanks for joining.